Hey guys, David here and welcome to another video. Today from a slightly different location, I want to talk to you about my DIY synthesizer build. Now, it's quite an undertaking building all the different parts of it completely from scratch, and if you're interested in that kind of stuff, or if you're interested in laser engraving, if you're interested in electronics at all, in building stuff, then this is going to be for you, even if you might not necessarily know too much about analog synthesizers yet. Before I get into the weeds of this video, I want to quickly thank today's sponsor, which is PCBWay. They make really high quality PCBs that I love using for all kinds of different projects. And currently they have a big end of the year sale going on where there's a bunch of different discounts and raffles where you can win stuff, and they also are more active on social media now, so you can check out their social media pages as well, where they're giving away even more cool stuff. So make sure to go check out PCBWay, linked down below. Now this will probably be a little bit of a lengthier video, so I'll hopefully put up some time codes and stuff so you can try to navigate a bit. And if you don't want to watch the whole thing, but of course if you want to get the most information, then go ahead and watch all the way through. Now first of all, I want to give you a little bit of background, since judging by my previous videos, most of you probably not too familiar with analog synthesizers. And basically what we're doing here is we're trying to create that very nostalgic sound that we had back in the day with those really beautiful synthesizers, but also at the same time we can use the same hardware to create really new and modern soundscapes, a lot of ambient stuff. There's a huge amount of possibilities out there that you can do, and if you build it all yourself, you can build the kind of things that are more towards what you want to do. Now, what the kind of style that I am building here is like a modular synthesizer. That means that instead of having one pre-done instrument that has certain sounds and where you can just change some settings to manipulate the sound, all the different parts of the synthesizer, like what generates the first sound wave and then the different stages of filtering and mixing together, they're all separate modules. And then I can interconnect these modules and have them loop back into each other and control each other to have a basically infinite amount of possibilities of what I can do with it. This is also commercial available. The style that I'm building in is called a Euro rack style. That just refers to the size of these modules and some of the properties, like what kind of power supply they use. So these modules would theoretically also be compatible with commercial ones. However, I'll be building all of mine, mostly because commercial ones are really quite expensive. You're easily paying a few $100s per module, and if to fill a rack you need quite a few modules, so you're looking at a few grand to build out a whole kit. However, building it yourself, there's a tremendous amount of resources out on the internet, because there's a lot of people interested in this, so you can find a lot of circuits. So even if you're not necessarily too familiar with electronics, there's still great ways to get into it, learn more about it, and as you learn you can modify the circuits more and more and really create your own stuff. Most of the stuff that I've built so far is just pre-done circuits that I found on the internet somewhere and then replicated. However, I did do some modifications, remove some controls, add some different controls, add another input, output, that kind of stuff. And then, of course, since I'm building basically one-off of everything and want to continue tweaking on it, I'm building it all on stripboard, where you just have copper strips in the back. You solder the stuff to, you disconnect some stuff, you put bridges in. It's a really quick way to build circuits from scratch without having to first make a PCB. But if I were to make more modules of one, or have a more complex module, making a PCB would be the easiest option, especially nowadays where you can get PCBs made for just $5. The price is not really a prohibiting factor anymore. It's more just that it's a lot quicker this way to prototype, and I usually don't build the circuit exactly like it was first designed. Now, before I get into the exact modules and talk more about the functionality of them, I want to just kind of give you an overview of the process that I use to build these quite professional looking modules. As of course, just having a breadboard with some wires coming off it is neither practical nor looks very nice. And since you probably watching this channel before, you might know that I'm really into 3D printing, laser cutting and all of that stuff. So I used the possibilities of a laser engraver to create very nice looking front panels. Alright, so here we are at the laser. It's a brand new enclosure that I built for it. If you haven't seen the video for that yet, make sure to go check it out. I just have a piece of wood on the engraving platform right now, where I'm gonna inscribe the outline so I can then position my metal piece correctly. So I just have the controller here set up that's just gonna engrave a quick outline. But now let me turn on my exhaust fan to be able to exhaust all the smoke outside. And then I'm gonna start the laser engraving. So what I'm using here is just a piece of aluminum, the right size that I have spray painted black, and using the laser I'm gonna remove all the lettering from this spray paint by burning it off, and then I should be left with the silver letters. So I'm gonna position this using the outlines that I just engraved into the wood board. So this is how it looks right off the laser. As you can see, there still is quite a bit of black in the lettering. That's just kind of like burnt up paint and stuff. So next step is going to be to scrub it with some water and the brush, and then it should become all nice and shiny. And here we go, a quick rinse later, and it's all nice and shiny and beautifully crisp. All that is left to do now is to drill out all the holes that are marked with these crosses, and then assemble the module. After that, it's just a case of assembling it, wiring everything up, and probably a few hours of troubleshooting, because it rarely works the first try. Especially like doing stuff on stripboard is very convenient, but it's also very easy to just kind of put it one hole too far, and then you have a resistor connected to something else, but it was supposed to connect everything to ground, and then you try to turn it on and just nothing happens. That then is, to some people, the fun of it, or to some people the reason why they prefer to go with kits instead of doing it all from scratch. But to me, the whole tinkering and trying to find what's wrong and going through it is quite fun. One tool that you basically cannot live without is an oscilloscope. Now, professional oscilloscopes are very cool, but also super expensive. So for the purposes of this, like a very cheap little PCB from China that is just a digital oscilloscope will do the trick. I've done all the debugging with this little thing, which costs less than 20 bucks. And while it does not have a very fast response rate or many features or a big screen or anything, it's good enough to see, is there a wave there? Is it's like a sine wave, triangle wave? Is it cut off in any way, that wave? And that's mostly what you need in debugging these kinds of modules anyhow. This enclosure here that you can see is just a very simple MDF construction. I cut out the pieces out of MDF, glued them together, painted it black. Quite a simple affair. Just the most difficult part of it basically was to get this front face, which is at an angle for the perfect size so that all the modules fit onto it. But that was just the case of some math. And after that, it went quite smoothly. I have space here, as you can see, for a crap ton of modules, but I want this to basically last me for a while. And with these modules, I cannot do that much yet, but I have a lot more modules planned that are gonna maybe fill it up to half, which then still leaves me with a lot of room for expansion. And now with like some of the general stuff out of the way, I want to go a bit more into detail on some specific modules. For simplicity's sake, I'm going to start at the very beginning of if you were going to play the synthesizer with a keyboard. There's also ways to not use the keyboard at all and just use the knobs and some like sequencers and whatnot to create more atmospheric stuff, but for the sake of this explanation, I'll start with a keyboard. I just have a very simple USB keyboard back here. It doesn't need to be this big. All it needs is a MIDI output. That's basically the standard in the music business for music data. And then that MIDI is fed into the input here, and it's basically the only digital part about this whole build. I'm using an Arduino here to take in the MIDI signal, which is digital, and then split it out into the different functions. For one, I have a voltage that specifies which note it is. These kind of synthesizers usually work with 1 volt per octave method. So a specific note has a voltage, and then the note that is 1 octave higher will have a voltage that is 1 volt higher. So this needs to be quite precise in the voltage if you want to then get notes that are actually in tune. So I used some precision analog to digital converters, since the ones from the Arduino are not sufficient at all for this purpose. But I don't just get information about the frequency of the note, I also get information when is a key pressed. That's just like a basic 1 or 0 gate, and I can then use that to turn on and off the volume or something like that. And there's also a bunch of other, in total I have set up 7 different outputs. I have different wheels on here that I can use for modulation and pitch bending and all of that, but these are just what they are usually assigned to. In actuality, they just give me out a voltage, so I can have the pitch bend wheel do either pitch bending, or I can have it change the sound in a different way, or do whatever I want with it. After I have this analog voltage that corresponds to the note that I want, I need a module to create a sound wave out of this voltage. And that's where a voltage-controlled oscillator comes in. The voltage controlled means that it can take, instead of just a potentiometer which you can adjust to adjust the pitch, it also accepts that a specific input voltage, in this case 1 volt per octave, that then allows you to have the pitch that you want. You still have a potentiometer where you can basically tune it and change the pitch up and down, and still very free, but this input then allows you to have some sort of easy connection to a traditional music scale. This oscillator then gives me just a very simple wave at the desired frequency on the output. On this one I can choose between a sawtooth wave, a triangle wave, or a square wave, and it doesn't really matter for now what the differences between them are. It's just basically that they have all slightly different sound characteristics to them, so depending on what kind of sound I'm going for, I might choose a different wave. Now, after that, you would typically go into something like a filter, which can filter out certain frequencies and shape your sound further. Now, I haven't quite gotten to the filter part yet. Actually, I've built it here, but I haven't been able to test it yet and haven't made the panel for it. So that'll be a task for a different video. And then the filter will, for example, on a sawtooth wave, typically you'll use something like the low pass filter, which lets through the lower frequencies but cuts off some of the really harsh high frequencies, so it'll kind of round off the tips of the sawtooth form of the signal. And then going through different like amplification modules and whatnot, you can then further shape it. Some of the other modules that I already have is something that's called a low frequency oscillator. Now, what this does is also an oscillator, just like the sound generation, but it's more for very slow frequencies. Like it starts at around like half a hertz to maybe like a few hundred hertz. Now that's not typically used for direct sound. Like while I could plug in speakers into that, it would be a very low note and not really what it is designed for. But instead what I can use this voltage for is the signal, a sound signal is just a voltage as well. And if it's a low oscillating, that just means that its voltage just goes up and down very slowly. And then I can use that to control, for example, my oscillator. This is also a great place to use an oscilloscope. You can kind of sort of hear the waves, but a lot of them sound very similar, and to adjust it properly you might want to actually see the wave. So plugging in an oscilloscope will easily allow you to see the wave and make a more informed decision on what you want to do. But just going out of an oscillator and some filters will just also still give you a continuous note. Like, it's not going to get louder or quieter, it's always going to be there, and depending on which key you press, it goes up and down. But if you want the note to actually stop and maybe fade in and stuff, what you need is an envelope generator. This, based on a signal, usually the gate signal that says, oh, there's a key pressed down, then creates a corresponding voltage that in the beginning rises up slowly. You can of course change the speed at which, and then once it is released, goes down again. And then that voltage can be fed into a voltage controlled amplifier. That basically is, instead of having a volume knob to change how loud the note is, it uses this input voltage. So when it is at 0 or you're not pressing a key, then there will be 0 output volume. And then when you press the key, the voltage slowly rises thanks to the envelope generator, and that will then make your note come in and get louder. Now, this is just like the very basics of what you can do. If you look at some other channels that focus more on this, it's insane what you can do. A lot of people then have huge setups with like dozens or hundreds of modules that they interconnect. It looks like something out of a sci-fi movie with cables going all over the place. But for now, I think this should be enough. If you have any parts of this process that you would like explained more or that you want to hear more about, leave a comment down below. If there's enough interest, I'll make more videos about this, and maybe also more in depth about a module in particular, how I build it or something like that. Just let me know what you want to see. Once again, a huge thanks to PCBWay for sponsoring this video. You can check them out at the link down below. And for me, that's it. Make sure to like, comment, subscribe, all that good stuff, and I'll see you next time.